and welcome. It's me, John Park, and this is MakeCode Live. Thanks for coming by today. Here we are. We're back together again. If you're coming here for the first time, this is where I'm going to build a MakeCode project for about the next hour or so and show you how it works. I've actually got a pretty cool hardware-based project today using a Circuit Playground Express and some NeoPixel RGB LEDs to make a really humongous 7-segment display. Gigantic version of what you find in a clock, for example. And we'll go over how you can do that all inside of MakeCode, how we can use it as a counter, how we can use it to just scroll through, some digits for us. And all done right inside of MakeCode. That's this thing. If you're not aware what this is a block-based coding editor. And we're going to use it for programming in kind of a visual way, so we can deal with the logic of what we're building. And if you want to join up in the chat, we're over in Twitch, as well as checking the chat in YouTube a little bit. And I'm actually going to take a look over in our chat over in Discord, particularly because I often get warnings about my audio there. So I'm hopeful that my audio levels are good, but oh yeah, we're a little low. All right, let me try to boost my mic audio without making it clip. This is sometimes a trick, just given my setup here. And partly it's just my proximity to the mic, so I'm going to move that a little bit too. We'll see how that is. Let me know if you hear any funny noises, but otherwise we're gonna get off to the races now. So what I've got today involves this sort of display. This is a 7-segment display. I'm gonna show you a little graphic here. This is a 7-segment display diagram that I found just on Wikipedia. And if you look at this, let me see if I can explain this. The way these work typically is that these are individual light-emitting diodes, and by sending power to them or closing the circuit so that power and ground make their way to each of these, you light them up. So to display something like a number 1, we would just light up these 2 segments that are on the right here, the right side here, this B segment and the C segment. If we want to do the number 3, we would light up A, B, G, C, and D. And there's also usually a little bit of a decimal point here. This is what this DP stands for, a decimal point. Sometimes there's other, let's like a colon. You'll see those between numbers on clocks, for example, between the hours and the minutes. So these are called 7-segment displays. This one is 7 segments plus an 8th LED that's this little dot. And this is a fairly typical naming convention, this A, B, C, D, E, F, and then G is this horizontal middle member here. And so we're going to use that in coding our own version, but we're going to make it out of NeoPixels. And so let me go back to this camera so we can see inside here a little bit. Let me see, can I move things off to the side enough? Sort of. They're right in my face. Let me move these over. So what you'll see in the display that I have here is that if I increment it, I'm using a button on the Circuit Playground Express. Each time I increment it, we'll see different, move this over just a little bit. Which way do we want to go? That way? Come in a little closer. I have this on a pretty heavy stand. I put a sandbag under it so it wouldn't fall over on me. As entertaining as that might be. And so you can see here, I'm just counting through the numbers 0, 1, 2, 3, and so on. But the way I've set this up is with just a single strand of NeoPixels. So it's just a flexible strip that has a bunch of NeoPixels on it. I've built this sort of complicated or at least labor-intensive display by using that one strip and then some acrylic panels to give me diffusion. But the key thing here, I think the key thing we're going to look at today is that MakeCode has the ability to make life easy when you want to address a big long strip of NeoPixels but you want to do so in sections or subsets of them, kind of logical subsets, even though the physical strip is one big long strip. So this is actually, there are 57 neopixels in this panel. And in fact, let me show you. I'm gonna pop over to the browser here for a second. I'm gonna show you what this looks like underneath. So I'm gonna go to learn.adafruit.com where I built a tutorial on this, and this is called the Ninja Timer project. And you can see there in the GIF, it's counting, and I've got these big displays. I just want to show you what's inside them. So I took this long strip, I cut it into little sections of 8 pixels each, and then I essentially soldered them back together in the shape of this 7 segment. And there's a good picture of what's going on. So we have all these segments. The tape is just holding the back of the board here temporarily so they don't go anywhere. And you can see I've labeled them kind of in reverse so that I get the numbering correct or the lettering correct. Here's some cool little connectors my friend Todd made to help assembling them be a little easier. So that's what our display looks like underneath. It's a whole bunch, 56 of these LEDs. The 57th one is a little dot that I have on mine. So underneath there now, the way NeoPixels work is when we address them in code, in MakeCode, we are gonna essentially tell the software that we have one strip that's got 57 pixels on it. And so what that, let me show you the code here for that. Let's see, I'm gonna throw my glasses so I can see this a little easier. It's just at that size and distance where I need the glasses. So I'm gonna look for my start block here. And I'll move this over a bit. So what's going on here, this is our typical set strip to tell the software that we have a NeoPixel strip and we're gonna use it. And it is connected to this little Circuit Playground Express right here. Let me move that a little bit so you can see it. It is connected to that LED panel just with, let me hide this display for 1 second, hold on. There we go. So it's connected to that panel over power, ground, that's the red and the black wires, and those are connected to the 3-volt output on the Circuit Playground Express and the ground to close the circuit. So that provides power. This yellow cable I have here is plugged into the analog 1 output, or the A1 output. I'm actually using it digitally. That's kind of a misnomer. And what that's being used for is to send data to the NeoPixels, telling them what color they should light at and what brightness. And that one data line travels across all of those pixels. Each one has essentially the ability to listen to a command telling it what to do and then pass that command on to the next one. So it's nice because it doesn't have, say, 56 or 57 connections to this board. That would be impossible with this kind of board. But instead, all the data telling the lights what to do that are in there travels over this one line. So if we look back at the code here, that's what this little piece of code, this block here, does. And we get it over in the light category. And if we head to NeoPixel, it's this second one right here. Set a strip to, sorry, it's this third one actually. Set a strip to create strip on a 1 with 30 pixels. So that's kind of your default. What I've done, I named it digit, but that could be called strip. In fact, I'm going to rename it strip here just to make it a little clearer. So I'm going to rename that variable, call it strip. So that's our NeoPixel strip. And that just automatically renamed it everywhere in the program, so we don't have to worry about changing it in a whole bunch of places. And that's telling the software that we have a 56, it actually should be 57, because I got that one extra dot, 57 pixel strip on A1. And initially this just sort of sets them to purple at a brightness of 30. And then the really cool thing is that this would be a pain in the neck if I wanted to do this number 3 that we have here without the added blocks that we're going to look at. Because if you think about it, this is pixel 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and so on. So if I wanted to light up this number 3, I would have to write some code that says, don't touch 0 through 7, but tell 8 all the way through whatever number this is to turn on purple, then skip these 8 pixels and then set these ones. So this would be kind of a mess because we're dealing with all these different ranges of neopixels that are on one strip. And so the really great thing is that there's this super convenient block. If I look back at the neopixel, so light neopixel section, actually I'm going to zoom out just a little bit so that's smaller. The scale of this is based on the scale of the canvas. They're all the same. And I'm going to scroll down to the bottom here and find, what am I looking for? I'm looking for the... Have I missed it? Maybe it's not at the bottom. Onboard strip. Oh, it's this one right here. It's way up at the top. I'm wrong. It's right under the one we used. So here it says strip. Happens to be picking strip 2 because we've already used strip 1. It doesn't want a conflict or strip. So this would say set a strip to be a new variable name. So we could call it like a subsection or a range or a substrip or a segment based on the way this LCD looking panel's partitioned up, to be our initial strip, so that thing that's 57 pixels long, but we'll make it a range that starts at a certain pixel number, 0 would be the first one, and goes for X number of pixels. So what I did was I set up a bunch of these and I put them into a function called create segments. So let's go take a look at that. That's going to be a whole bunch of that block I just showed there. So create segments. Open this up here. So you can see here, it's that same block just used a few times. And I gave them helpful names. So I'm going to put that right there. Move out of the way. So you can see here, set segment A, and that's traditionally this one right here, actually, right? Yeah, A, B, C, D, E, F, G. So sorry, I was screwing that up earlier. So segment A is going to be a strip ranging from, to confuse matters, where I decided to place the data line isn't at what we consider A. So sorry about that. But I actually have my data line starting there, so that's actually what we're going to call F. So we'll see there's this set segment F to be our strip, and it's going to be a subset or a range that starts at 0, that's where 0 is, and goes up through 8 pixels, that is, so 0 through 7. Then we have segment A, so that's this one. This one happens to be the physical pixel number 8, and that's going to go 8, and then it's also 8 long. So you'll see all of these, you can tell how long your segment is, and this can be anything. We could have a segment that's 2 long and one that's 55 long and use them that way. It doesn't care. You can partition them. You can't have them overlap, though. As far as I know, I saw some issues when I had my math wrong before, so I think you can't overlap the ranges or it gets confused, which makes sense. And so this is segment A, B, C, D, E, F, and G. And that means I can now tell individual segments to turn on or off by calling them here. And then under the hood, it will take care of the math of which real numbers are in there, which is hugely convenient. And so let's take a look at continuing this experiment here. So this is kind of a not an optimized way to do it, but I think it's a really clear way. And then I'll show you an optimized way to do some of this stuff. So now that I have individual segments that I can talk to, what we want to do is construct essentially some kind of a lookup table for this sort of thing. So you'll see here, these are which segment names you want to call to do individual characters. So to do a number 2, character, or to put the 2 on here, we'll call A, B, G, E, and D. To do the 3, it's A, B, G, C, and D, and so on. So we essentially want to construct a version of that inside of MakeCode. And so I'll show you, this is a very, hopefully a clear way, even though it's a bit brute force and not optimized, like I said, to accomplish that. So why don't we take a look at the number 1. So here I have created, that one I'm trying to be a little clever on. Let me uncollapse or expand all these blocks, format my code. Okay, there's a nice example. So the character for a 6, move this over here a little bit. So the character for the 6 is a function where I can call this and just say, hey, I want to draw a 6 on the screen. And so the way I'm doing that is I'm saying set segment A, which is this one. In fact, let's go up to a 6 right now so we can follow along. Okay, so here's a segment A, which is that one. Segment A is off, so I'm just set all the pixels of segment A to black, and segment B is off, so set that to black, and then C, D, E, F, and G, those are all on. And so we could do something like just put a color in there. That makes it, that's sort of how it comes by default. You can just pop a color in there. I decided to add a second layer of coolness on here, which is when I call the function, I can tell it what color to be. And I chose hue to do this. You could choose indexed RGB colors or RGB itself. So that's how I've set up all of these. If you scroll out, or if I scroll out here, you'll see I've just made a whole bunch of these. This is my lookup table for, here's an 8. 8 is all of them are on. So A, B, C, D, E, F, G all have the same color. And I think in this version I'm not talking to the dot, so that's actually why I had this one set to 56 to start with. Now, if I want to call those, all I need to do in my code is run this character 6, char 6, and give it a hue value, and it'll light it up. Now, we can demo that version. So I've got this Circuit Playground Express plugged in over USB. So that means I can upload code to it directly. What I'll do is let's pair the device in here, and let's see, that should. There we go. So this little icon here shows USB connection. So using Chrome browser, which I'm using here, this has web USB, so it allows USB to work from the Chrome browser. It can push the code directly there. And now I'm trying to remember, what does this version of this code do? Because I messed with a second one after this one. So let's see. Forever cycle the letters. Okay. So let's see. I think what this will do is I set up some of the letters that you can draw. A, B. B is kind of an 8. A, C, E, and so on. Kind of the stuff that you might have tried on your calculator a long time ago to spell things out. So this should cycle through those. I'm going to download the code. So that's actually uploading it to that board. And there it goes. Okay, let's see, did it work? It didn't. Okay, so I am gonna do it manually, which is it's kind of a lot to ask the computer given all the things I'm doing right now streaming this. So I'm gonna download the UF2 file, and I'm just gonna simply drag this onto the drive that shows up when I plug this in. So let's hide that for a second. Let me drag that code on there. Hopefully I don't break things. There we go. So this is going to now move this out of the way. This is going to just cycle through the character set that I gave it. So I made a series of these. You can see A, E, F, H, J, L, P, H, A, and so on. So it's just cycling through those by calling those functions bring these back up so we can see them. So functions here such as, let me go ahead and collapse the blocks and format the code so it's all near each other. I am now so reliant on this. I don't know how we lived without it. Okay, so here's, for example, the F character, the little lookup table for that, the J, the E, the H. And then to test those, I have this. Like I said, this is just kind of brute force. There's nothing optimized about it. This is just calling the character A and telling it a hue to be, which is this kind of bluish color that I gave it. Then it pauses some value that I give it as well, this variable called speed, and then it moves on through A, C, E, F, and so on. If we look, I think in the start block is where I've set the hue. Value and the speed value, or no, I'm doing that when I go to my forever block. Let's open that up. So here I'm calling it to cycle the letters. This is the speed, so 1000. Let's set that to twice as fast, so 500 milliseconds. And then the hue, that is a color wheel that runs kind of in the real world. It runs from 0 to 360 degrees. It's a arc, a circle of hues. In MakeCode, that's 0 to 255, which makes it more consistent with some other color things. At least I think. Yeah, I don't think it goes up to 360. So if we go to 0, this is actually the red position on the color wheel. So if we try to, let's see if we can re-download that. Re-upload that. There it goes. So now it's telling it to cycle through these letters twice as fast. Oh, I see. It's actually pushing the code there, and then it's sort of trying a second time and getting confused. So I can close that. It actually worked. So now it's running all of those individual functions. They're all getting that same argument for speed, which is now half a second or 500 milliseconds, and they're getting that argument for hue of 0, which is red. Now directly across the color wheel from this should be the halfway point. So if we're going 0 to 255, I should be able to go to about 123 to go to blue. So let's try that. We'll call this with 120, let's say. And I'll try to convince it that we're connected. Push that up, and we should see this now pop back up, but now it's using a blue color. And I think my colors are fairly accurate to what you're seeing, maybe a little more saturated here, but I've actually made a little camera selector for my webcam that should allow me to go to a sort of a darker mode where you'll see the colors a little better. So that's our basic example. Let me switch the camera back to this one. Oh, that's a little blown out. Hold on. This is what I get for fiddling with camera midstream. Where did you go, little... I think I've exploded the webcam settings app. That's what I use, by the way, if you're curious, to tune my webcam. And since so many people are using webcams these days, I recommend getting a little secondary app such as webcam settings if you're on the Mac that lets you override a lot of settings for things like gain and brightness, color saturation, color temperature, that kind of stuff. Okay, so now what's difficult about doing it this way, which is these sort of functions that each one kind of sets in stone which segments it can light up, is that it is a little hard to programmatically deal with it. So I can't increment a number and just have that value show up on here so easily. So what I've got is a second version. Let's see if this one is still intact. It's not. Okay, let me load. Let me go to the home here. Yeah, in the Chrome browser, sometimes MakeCode will if you have multiple tabs open and you change your code in one of them, it'll update them in all of them, even if it's saved as different names. So let's see. I'm gonna drag. I've saved a copy of the UF2. Which one are you? Are you gonna be optimized? This one here. How about? Aha, here we are. Okay. So this one, actually, I got help from my friend Todd, who's Toddbot in the chat there, if you're looking over at the Discord chat. And I should actually peek in there and make sure no one's telling me any problems with my voice level. Looks like we're good. Okay. And I'm just checking the various chats real quick since I've mentioned it. Let's see. Good, good, good. All right. Everything's working. Hooray. So what I've got, so I talked to my friend Todd about this, and I said, okay, I want to, this is the approach that I've got that's a very rote kind of brute force way to say this is which set of segments I light up in a function. But it's not super flexible. So what Todd, he thought about it a bit, and what he came up with really worked out great, worked out perfectly. So this is the code that you saw that I had on it first, and we'll re-upload this to mess with it in a moment. But actually, here is a really nice description of what we're going to do with a couple of arrays. So the idea behind this is that we're going to create an array, and if you head over, if you need an array, you head over to the advanced category and look at arrays. And here you can create an array, which is essentially a list of items. And they can either be numbers or they can be characters, text, like a string, this is sometimes called. So we have a list and we have a text list. So what we have here is a text list. And I gave these really big, long descriptive names so that I would remember what things are and make it clear. Often in coding, you'll use names that have no spaces in them and are short because you don't want your lines to run on forever. But I realized that this would be a little clearer if I gave them useful names. So my list here, it describes itself. It's list of numbers as segments. So this is a set of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sets of segments that correspond to lighting up a 0, a 1, a 2, and so on. So if you look at the second item, it's B and C. As we remember looking at this, B and C are the two segments off on the right, and so that's what gives us the number 1. So this is our kind of Rosetta Stone or map to which segments by letter we need to light up in order to have a complete digit show up. So with that stored here, the next thing we can do is tell it a number that we want to display. So when this starts up, the first thing it does is it tries to display a 0. And we can ignore this one right now, this counting Boolean. That's going to be useful when we want to do something like this, which is tick up the numbers. And then I'm calling a function called call show segments for a number. So let's find that. I'm going to collapse the blocks and I'm going to format the code. Show segments for a number. That's this one right here. So let's have a look at this. Let's see, can I get it far enough over? Yeah. So show segments for a number. What this is going to do, first thing is it sets a variable called segments to light. So which of these are we going to light up? Segments to light is set to be a list of numbers as segments. That was that thing we just looked at. Let me open that up so we can compare them. So on start, list of numbers as segments. And I'm going to put that over here and this here, and I'll live in between the two of them. So get up there. That's pretty good. Okay, so this variable called segments to light. Which ones do we light up? We take the list of numbers as segments, and we get the value at the number to display. Now remember, we said the number we wanted to display at first is the number 0. So that means we're going to ask for the 0 item in this list. This is a 0 indexed list, so it's essentially the first item. But the answer right now to what does this variable equal is it equals A, B, C, D, E, F, which is all of the outer segments, excluding that center one. So the next thing I'm going to do is I'm going to set the whole strip to black. I just want to turn it off. Then what we'll do is run through this loop, which is an index from 0 to whatever the number of segments we have to light up. So this 0 has 6 segments, these outer segments, and it's arriving at that by looking at this length of this variable called segments to light. So it looks at that string that's in there and it says how many things are in it, and it finds its answer, which is going to be 6. So from an index going from 0 to 6, it's going to set the individual segment variable, it's a new variable, to be a substring of this segments to light from index to length 1. What does that mean? That means that the code is able to look at this and run through it multiple times using just one of these string characters at a time, each iteration through. So it'll run through it once with that variable equaling A, then B, then C, then D, then E, and then F. And they don't have to be in order. Here you can see I've got one listed as A, B. Uh-oh, now I've done it. I've got one listed as A, B, G, E, D. It doesn't matter what order they're in. It's going to run through each item in that string, and each time this for loop goes through, it's going to do its thing, whatever's inside that green block, with the current character, that current string character. So that means the first run through, it's an A. So with this variable equaling an A, it then does this big comparison that just says, what character do we have right here? Is it an A? Is it a B? And so on. Whichever one it's true for, it does the thing inside of here. So that first time through, it's an A. And so we finally call a thing that turns on some pixels, which is set the segment A. Remember, that's our subset, that little range that's a subset, 8 pixels within this 57 pixel strip. Set those to whatever the strip color is meant to be. That's a variable we set elsewhere. So when it goes through and it finds a C, then it's going to light the C segment. When it finds an E, it lights the E segment, and so on. So that's how we go through and tell each of the segments we want to light to be lit up. So we first turned it all off using this black, set the pixels to black. Then we've gone through and said, here's all the ones to light. Once we're finished with that loop, once we get out of that loop, because we've gone through however many we needed to in there, we'll also check if we're calling the little decimal point to be on or off. We'll look at that in a moment. And then finally, we show the NeoPixel strip. So this is, we don't use this one a lot, but what this is actually really interesting. This allows us to buffer or store some commands up saying, what should we light? But don't actually turn them on until they're all prepped and staged and ready, and then we say, okay, show. Normally, if you tell a NeoPixel what color to be, it'll just immediately change this to that color. What I found, however, is that I was sensing a little bit of a delay. And so I would see some segments light, and then like a fraction of a second later, we would see some others light. And I want them to kind of all burst onto screen. So let's, in fact, let's upload this code right now. We'll see if that successfully uploads. And we'll see it in action. So there we go. When I, so this lit that 0, right? That's what's happened in this start block. Let me collapse my blocks and format the code. And go back over here. I can actually mush that up a little bit. So this all just happened. And at the end of this, it said show the segment for a number, which was that function we just looked at. So it just went through and did that. And now we have this 0 looking at us. The reason that it's buffering is that I added a NeoPixel block here called set NeoPixel strip buffered. And then you can set that either to true or false. That should be true, right? I wonder why that's... Maybe I changed that by accident. Let's read the description, the tooltip on this one. If we hover over it, we should get enable or disable automatically calling show. Yeah, I think this should be set to buffered, right? Let's see. Does it look... Let's see if we detect the lag. I see a little bit. That might just be how long it takes to talk to all those neopixels. Let's re-download it, though, now that we set buffered to true. I want to see if that actually changes, or if I imagined it. Okay, this is going slower. You can see... Yeah, so why is that set to false? I can't remember. All right, we'll take it on faith. That's the right... I must have it backwards in my mind. If anyone knows, tell me in the chat. I just can't remember if in MakeCode buffered wants to be true or false to have it show on or off. Okay, so now let's zoom back out on here. The next thing is how I'm actually using the buttons to call these. So this is nice because now that we can call this function and tell it a number, we can do this a little more programmatically. So if I look at, let's say, button A and button B, what's happening when we click these? So let's look at button B. That's the one on the right. On button B, click. We're going to set the variable called number to display, which number are we trying to show, to whatever it was to begin with, plus 1. So when this launches, it's at 0. That's what we set that variable to be. When we press B, it's going to increase that number by 1. So it takes whatever it was and adds 1 to it. Then it's going to set the display to be whatever that number is. It's going to take that same variable and it's going to massage it further. So first thing is we take the number to display. It was 0. Then we add 1 to it. Now it's 1. Next thing we do is we just make sure that it never goes higher than 9. So this is a way to, whatever the real number is, if we get to 9 and we add 1 to it, we can't display a 10 on here because I've only got one digit. So we need to loop that back around to 0. And the way we do that is with this function here that's sometimes called modulo. And this is, the math behind it is it's the remainder of a division operation, which is take that number to display, whatever it is. So let's say we were at 9, we press plus 1, it becomes 10. So take 10, divide it by the length of the array in the list of numbers as segments. And you'll remember we had 10. So the remainder of that division right now is 0. We can go 0 through 9, so that's 10 segments, or 10 possible characters or digits. And when we divide that total number of 10 by 10, it goes in evenly, and the remainder of that division operation is 0. So that essentially changes our number to 0. And that allows us to keep looping through 0 through 9 forever and ever. So the B button will change, in this case, that variable number to display to be a 1. And then we call that same show segments for a number. So we'll do that once. This is the B button. Let me put my Circuit Playground Express back in view. How about... There you are. And so I'll press the B button, and now it'll increment to 2, and so on. It's going to keep going until it reaches 9, and then the next time through, it just flips back to 0. The A button is actually a little more, just slightly more complicated, and that's because I can't go negative. I don't want the numbers to go negative because it doesn't have a way to display that. I suppose we could use the little dot on there, which I keep talking about and you can't see. So we'll show that in a minute. Let me see if I can scoot this display over a little bit. 1 second. Unlock a thing and move you over. There you go. So you see that little dot right there? That's the dot I keep talking about. But we won't use that right now. So when we want to go negative with this, the only change I had to make we're these two things. First of all, we're subtracting. So whatever the current number is, let's say it's a 1 right now. I'm going to subtract 1 from it. That'll make it a 0. And then I essentially want it to not subtract. There's probably many ways you could do this, but I decided to just say, if we get to 0, stop right there. So it can never go lower than 0. And the way I'm doing that is I put this conditional statement here that checks to see, is the number you're trying to display greater than 0? If it's at 0, or essentially it'll never get lower than 0. So if it's at 0, it just doesn't do anything below. So nothing happens. We can make it beep or something if we wanted to. So we can go up and we can go down, but we're never going to go below 0. And these are kinds of things you have to think about when you're doing things with displays, counters, and clocks. There's some interesting little challenges that come along when you do these types of projects. Let's make this a little bigger. Here we go. So now what I wanted to do is add a couple of bonus features. So one thing is color. If you look at the way I'm handling color right now, let's collapse all the blocks. Format the code. Let's look in the start block. So in this start block, I have a variable called strip color, which I set to pink. So if I just change this, let's make it red and re-upload the code, it's just going to change everything. Everything will follow that one variable that I'm setting, which is from an index of colors, and or so I say. Let's see if it really... That's not red at all. Do I have it somewhere else? I wonder. Why are you not changing? I don't think I have it somewhere else. That's definitely not red. All right, let's change it to green. I really want to make sure that I didn't break something here. Otherwise, I'm confused as to where it's finding out what color to be. There it is. Okay. Oh, we're kind of one download behind here, so something's going on with the way it's resetting itself. So I'll leave it at that, or I could drag the code on when we do that. So I'll drag this code that said green. That's funny here. We're one behind what I think I've downloaded. All right. That thinks it's green. Oh, sorry, I gave it the wrong version. That was our old previous version. So I'm going to hit save here. That's going to save the UF2 file to disk. And now I'll drag that on. This time I'm so confident it's going to be green. Get ready for it. Yay, it's green. It's a little bluish green, but it's green. Okay, so this is one way to get the color. I've got it in one location here in the beginning of the code. I'm just saying we're going to do everything as green. However, since we're calling these functions and telling them to light up, we could also tell them to have different colors when we light them. That is right here. This variable strip color is being used. So that right now is what's telling it the color to use. However, what I decided to do was give myself a way to change the color while the program is running, and that's with this A/B function. So you can press the A and B button at the same time, which is nice. It gives you kind of a third interface option for the buttons. A will go decrement the numbers, B will increment the numbers. A and B at the same time will set the strip color, that variable we're using all over the place, to be a randomized version of red, green, and blue, where it can pick anything from 0 to 255, which is the full range, off to 255 brightness of each of those diodes in there, the red, green, and blue diodes, and then call the show segments for numbers. This won't change the number that's currently displayed, it'll just change the color. So if I press the two of these at the same time, we just get random colors, and we can just press that. There's white. That meant all of them were on pretty bright. It's a dimmer version. There's a reddish. So it could take a long time to get something you like because we have so much randomization available. There was one that was mostly off. I haven't seen that before. It was a nice pink. And then everything else will function the same. And again, this is all made really easy by that lovely NeoPixel set strip to range thing, because I get to call these segment ranges instead of big slews of numbers or cycling through big lists of numbers. Let me just check the chat, by the way, in case anyone has any thoughts or questions. I don't want to ignore. Oh yeah, hello, welcome. Some people over in YouTube, and yes, we are live. It's fun to get in on it live, isn't it? I know we can watch these archived later, but this one's happening right now. So I can't pronounce your username, but it looks like Hugh. Welcome. Thanks for stopping by the YouTube chat. And let's see. So if I go back to the program here, I'm going to show you just a couple other little added features. So let's collapse all the blocks again. You'll see I did want to use that one little dot. So I have a couple of ways to engage that decimal point, and that is with this on switch move left and on switch moved right. These are changing a Boolean, which is a true false or on off. These are changing a Boolean variable called point on to either off when I go left or on when I go right. When they're called, they will set the pixel, which I'm calling the segment point. So I have seg A, B, C, D, E, F, G, and seg point. And I'll show you where those are created. Not there. Here, create the segments. So that's this last one here. And this is just the last NeoPixel. So it's pixel number 57, and it's a range of 1 pixel. We could have just called it 57, but I wanted to stay consistent. And just so you understand what I mean by that last statement, you can always call a particular NeoPixel with this block right here. Set strip pixel color at 57 to, and pick a color. That would set that decimal point to yellow as well. So here, this will turn them on and off. Where's my switch? There it is. So the little switch here. You can see it turns that little NeoPixel on and off. But what I noticed when I did that at first is that if I set it to on and then tried incrementing or decrementing my numbers, it was turning off. And that's because if you remember what my function that shows segments does, one of the first things it does is it turns all of them off. And then it only has to turn on the ones that are needed. So this NeoPixel strip all to black, boom, it would turn everything off. And then my little segment thing here, oh good, I've got the ringer on the phone. This little segment here will turn on all of the segments necessary for the character we're doing, but I had to add a little extra bit here that said if the point on variable, which the switch sets, is on, then we'll also set that segment point, decimal place point on. Otherwise, we'll leave it off or set it to black. I could actually have else do nothing there because it would not be trying to turn on a thing that's off. So that's how I'm using the switch on there. And then the last thing I wanted to do was have a way to have this just act as a counter and count some time step like a second or a minute. So the way I'm gonna interact with that is using the accelerometer that's built onto the Circuit Playground Express. So there's a pair of blocks here that I can use. One is called tilt left. The other is tilt right. And these blocks are available. Let me open these up here. These are available right here in the input category. So there's our button clicks, there's shake. So if you grab that shake block, then you can use some other accelerometer things which detect which way the thing is turned, or if you're shaking it or if you're dropping it. So with tilt left, I have a variable called start counting, gets turned true. And on tilt right, I have a variable called start counting, and that's set to false. So all these do is change a variable. So where is that variable actually doing something? That is what's happening in this forever block. So if I tilt it left, it'll change the variable. If I tilt it right, it'll change the variable. This forever block is always looking to see the state of that variable. Should we be doing whatever is in this if block or not? So when that variable set to true, when I've tilted this thing left, I think it was left, then it's going to set the number display to add 1, just like we do when we press the button. It's going to call the show segment, and then it's just going to pause for a second. So let's see that in action. If I tilt this, just the act of tilting it turns that on. It actually doesn't need to stay tilted in this direction. It's essentially a switch. It just says, did I notice a tilt to the right, or rather to its left if you're looking at it from the front. And then the other block is we'll turn it off by tilting to the right. Hello? So I thought. No, it's not working. There we go. Oh, I have to tilt it all the way. Earlier that was, I guess, a little touchy. I think if I go just a little beyond 12 o'clock position, it calls that off. No? I do have to go all the way. Okay, so that's on and that's off. And until it gets far enough over to call it tilt right, you can center it back up. So one reason that works really well that I love is MakeCode has these concurrent threads. It can do multiple things at once. So it can be thinking about doing these pauses, but you could still interact with it to change the color because it doesn't block the code. I say this, I don't think I've tested it. Have I tested it? Let's find out if I'm true. So here I have it tilted. It's doing its little 1 second, but every time I press A and B together, I don't have to wait a second to kind of slip that command in between. It allows me to change the color while it's doing its other thing. Ooh, that's a nice blue. I'm going to leave it at that. We'll turn that back off. We can also, actually, while it's going, we could turn the decimal point on and off. And it reacts immediately because this is multi-threaded. So there you go. That is a little bit about how you can use the super cool NeoPixel range blocks that live right here in light NeoPixel. This set a strip to a strip range from number to how many. To be able to talk to a big, long, huge strip of NeoPixels, which I'll just remind you, that's I don't think I have one right here to show you, unfortunately, but it's that. It's a big, long strip. It doesn't necessarily have to be all fancy and cut like this. You could do some twisting and a bit of origami with it. As long as you don't break them, they're pretty forgiving. If you do cut them, you can resolder them at these break points. And here's a large version of it. There you go. So those are these 8-pixel strips, and I start here, run all the way around, and end here. That one's not connected. I think I actually connected that to power and ground there, but not to data. So that is our MakeCode Live for today. I hope you enjoyed it. If you've got any questions, I'll be over in the chat. You can pop over to, right now, the YouTube or the Twitch chat. Dreadmask197 asks, are we using the beta version? Yes, I am. I think there may not be anything in here I'm doing today that requires beta, but I just am in the habit of using beta. It may be that the code collapsing and formatting is still just in beta, and I can't live without that. So that's why I'm using beta. Any questions over in the I'll check the Discord chat as well, and I'll be watching the Discord chat a little bit after the show too if you have follow-ups or questions. Fede2 says, love the huge 7 segment. Thank you. Yeah, I built this originally to do a large obstacle course timer. I built multiple of these and had a whole control system for them with big buttons. In fact, you can see one of the big buttons is right behind me there. That's a big stalk for hitting a button when you climb over the warped wall in a Ninja Warrior course. But they're useful for other things. You could go do like I said, some letters with this, so you can spell out some but not all words. Or Or you could make a fancier version that uses the X, I forget what those are called, but like the this is a 14 segment display, the ones that have kind of X's so you can get W's and stuff. And let's see. Oh, functions with arguments is only in the beta. Todd Bot says, thank you for reminding me. Yeah, so the fact that I'm calling functions, no, there's arguments. I think returns are new in the beta. I think functions with arguments have been around. But you can always, if you want to check out this code, you can, I'll hit share right now, and that'll allow me to bring up a publish project window. There is the QR code. There's the URL. And I think I can click on that. So if you just point a webcam or a phone with a QR code reader at it, that'll take you to this code. And have a look at how that's made. So I think that's all we got for today. There's going to be, I think, another MakeCode show scheduled next. If you go to the Twitch page for MakeCode, that's twitch.tv/MSMakeCode. I believe there's a schedule you can look at that tells you there's a MakeCode Arcade Advanced coming right up. So stay tuned for that. There'll be lots of good stuff, I'm sure. For Microsoft, MakeCode team, and Adafruit Industries, I'm John Park, and I will see you next Tuesday with more MakeCode Live. And if you want to see some more of this similar type of content, go to the YouTube and other video channels for Adafruit, and you can check out, there'll be a show and tell and an Ask an Engineer, a 3D Hangouts with Noe and Pedro. I'll be doing a workshop show on Thursday, as well as another show and tell. I think Scott will be live streaming on Friday, doing some live coding. So come on over. There's lots of good content there as well. Thank you so much, and I will see you next week. Bye-bye.